So I was sent this video that globies can't explain. So here I am as a globie to take a couple of the major points from the video and explain them. So number one, they tell us the Earth rotates once every 24 hours, but it's really 23 hours, 56 minutes, and 4 seconds, which is true. The Earth spins around its axis once every 23 hours, 56 minutes, 4 seconds. And this is called a sidereal day. It's the time it takes for a fixed star to come back to exactly the same spot in the sky. So in this diagram, you can see the Earth is looking at the Sun. So if we move time 23 hours, 56 minutes, 4 seconds, we are here and also looking in the same exact direction. So this is a sidereal day. But to complete a solar day, we need to rotate a little bit more, so we're looking at the Sun, which takes a little bit of extra time. And the average for a solar day is 24 hours. Next, it asks if we ever seen an accurate diagram of the Earth's orbit. So I made one. This is a scale diagram of the Earth, Sun, and Moon. The Sun is in the middle, and I can zoom into the Earth and Moon. So as you can see, Earth's orbit is very nearly circular, and this is why diagrams exaggerate it, to make it very clear for educational purposes which part is closest to the Sun and which part is farthest from the Sun. So number 3, it asks why the solstice isn't 90 degrees to the equinox. And that's because the graph in your video is mislabeled. You have the equinox labeled directly between July 3rd and January 3rd, but the actual day between them is October 2nd. But the fall equinox is really September 22nd. So if we add a perpendicular line to your diagram, you can see that these intersection points line up very nicely to where we'd expect the real equinox dates of September 22nd and March 20th to be. The rest of the video attributes the east to west motion of the Analemma to Earth speeding up and slowing down in its orbit. So let's actually see why this is false. So I have a scene here with the Earth and the Sun. This circle here is called the ecliptic, and it's the circle the Earth lies on when it goes around the Sun. It's basically just its orbit. And this graph shows that the rotation of this circle is perfectly smooth. It's not speeding up or slowing down. Every frame it rotates by 10 degrees. This new circle is called the celestial equator. The line on it is pointing directly out from a spot on the Earth's equator. When this line points at the Sun from a top view, it's solar noon for your longitude. So in this animation, every frame is noon 1 day apart. I'm not animating the spin of the Earth between days, so we have a snapshot of noon, and another, and so on. And this animation also only has 36 days, because I didn't want to animate 365, but the same logic applies. So since a solar day means it's looking at the Sun, after this whole thing, it needs to look at the Sun again. So across 360 degrees and 36 days, every day, every snapshot, every frame should be rotated 10 degrees further from where it was. So you can see it's out straight, now it's down 10 degrees, now it's down 20 degrees, 30, 40, yada, 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 all the way around. So now if we look at this animation, you can see the line where the Sun looks at the Earth makes a figure 8 shape. So the analemma isn't being caused by speeding up and slowing down. It's just because the Earth here is tilted. So I'm going to do almost the same thing here, just with one little difference. If we look at the animation graph for the Earth's orbit, you can see it's slightly faster in the middle, just like Earth in January moves at its fastest because it's closest to the Sun. And I just also want to note the Earth's rotation here is still constant because 24 hours is the average solar day. So each snapshot here is going to be 10 degrees, 10 degrees, 10 degrees. So now if we look at where the line of the Sun intersects Earth, it makes an asymmetrical analemma. So It's only the Earth's tilt that causes it to cross over itself and go back and forth and back and forth. But the reason one loop is bigger and one loop is smaller is because the Earth is slightly slowing down.